Okay, so the second review for Math 1, if you remember, is all about linear and exponential functions. And if you remember, we're going to combine that with the arithmetic and geometric sequences. This is a big part of math, and it continues into Math 2 and sometimes even into Math 3. So let's take a look here. A linear function, you know, right, when you graph this, right, it ends up being a function. It's a function whose graph is a line. Okay, now remember this stems from what we call an arithmetic sequence. Okay, and that means when we have an arithmetic sequence, you have to remember that's when we have what we call, right, a common difference. Okay, that's how we recognize it. And with this, remember, the common difference is also basically the slope of the line, or the slope of the line is also known as that rate of change. Okay, now with this, we have two types of rules we write. We have the explicit rule, and then we have the recursive rule. Okay, and with that, right, the recursive is important, but the explicit is probably the most important. Now with the explicit rule, right, remember, this is just basically your function notation. There's one way, if you know the y-intercept, we say f of x equals mx plus b, where m represents your slope, b represents your y-intercept. Okay, now here's the thing though. If you're given a point that's not, right, if you're given a point that's not the y-intercept, so say you're given some random point x1, y1, we say the explicit rule would be f of x equals m times x minus x1 plus y1. This is probably the best form to know. Not only can you write the equation so quickly and efficiently there, but at the same time you can gather an ordered pair and a slope and graph it real quickly also. Now the recursive. If you remember in a recursive, the first thing is to determine that first, determine that first term. And with that, we basically say f of the number equals a number. So you're basically just telling us where we're starting this, function at. Then, if you remember, the recursive, uses that, previous term idea, right? And if you remember, f of x, equals f of x minus 1 plus or minus that common difference. Okay, so remember, this represents that previous term. Okay, and we'll look at a couple of examples here in a minute. Okay, so that's a linear function. Now, exponential function, right? This basically is a graph of an, exponential curve or function, which is a graph that either starts low and goes high real quick, which would be exponential growth, right? Or this graph can start high and decline or decay real quick. We call that exponential decay. All right. Now remember, this function stems from a geometric sequence. Okay. And this geometric sequence gives you what we call a common ratio, right? So we recognize a geometric sequence because we are multiplying or dividing the previous term each time, which is that common ratio. Okay, so right away when we look at this, we have to write the recursive and explicit rule for this. Now, the explicit rule. The explicit rule for an exponential function is f of x equals a times b to the x, where a represents your initial value and b represents your common ratio. Okay? So next, the recursive rule for this, remember, right? You have what we call this common ratio, and when we have this common ratio, the recursive rule uses that now. Oop, gotta know how to spell here. So the recursive rule here, right, is going to be, again, identify your first term. So f of a number equals a number. And then it's going to be f of x equals your common ratio times your previous term, which is f of x minus 1. Okay, so when we look at this, it's knowing which one you have. Do you have a common difference or a common ratio? And knowing what formulas to use. So let's take look at a couple of examples here. So anytime you get these, remember, back in the day, we always stressed you guys to make a table. You need to determine where you're starting at. Here it's starting at stage 1. So if I call this x for input and then f of x, I know we started at stage 1 and we had 4 dots. Then stage 2 had 7 dots. Stage 3 has 10. And stage 4 has 13. And if I look here, what is happening here? Am I adding or multiplying the same amount each time? What I'm basically doing is I'm going up 3 each time. So that tells me my common difference is 3 and that this is arithmetic. So this is an arithmetic sequence. Alright, because it has a common ratio and we're adding to the previous term each time. So this would have a common difference. And before we can answer C, we're better off looking for the explicit rule. This is one big reason why we find the explicit rule. So if my common difference is 3, that tells me my slope is 3. Right? So m is 3, and I have an ordered pair that I'm just going to take here. And I'm just going to pick 1, 4. It doesn't matter which one you pick, but I'm going to use 1, 4. So that acts as my x1 and my y1. So my explicit rule would be f of x equals my slope 3 times x minus the x coordinate of the ordered pair I'm using plus the y coordinate I would use, which is 4. Okay? Now, that rule helps me answer, letter C. If this is a 20th stage, x is equal to 20. So now f of 20 would be 3 times 20 minus 1 plus 4, which gives me 3 times 19 plus 4. And right away, that tells you there'd be 61 dots. right, in the 20th stage. Now the recursive rule, right away I know my common ratio is, my common difference is 3, right? And I'm going to first start with my first term. So f of 1 is equal to 4. Then the second part of the recursive is f of x equals my previous term, f of x minus 1, and I'm adding 3 each time, so plus 3. So in this next example, if we go ahead and we make a chart, now I do want to bring something to your attention here with the chart here. If it says at the beginning, right, that means your time is starting at 0. So you would have 0, 3, then 1, 6, then 2, 12, and then 3, 24. Okay? So right away when we look at the pattern here, what are we doing? Well, this goes up 3, up 6, up 12. Right away, that is not a linear or arithmetic sequence. This would be, if I multiply by 2, multiply by 2, multiply by 2, this tells me I have a geometric sequence. Okay? And that this, right, the times 2, that's our common ratio. Okay? Now, how many x's would there be after 8 minutes? Well, let's go ahead and write, right, the explicit formula. And remember, in the explicit formula, it's a times b to the x, where a is that initial amount, right, and b is that common ratio. So f of x equals my initial amount. How many x's did I have at the beginning? 3, right? Times, what was my common ratio? 2 to the x power. Okay? Now, that makes this letter C easier to answer now, because what is f of 8 going to be? Well, 3 times 2 to the 8th power, right? If I plug that in my calculator exactly the way I see it, right? If you do 2 to the 8th and then you multiply that by 3, you would get 768 x's. Okay? Now the recursive rule. Remember, for your recursive rule, you're going to start with your initial amount, stating it. F of 0 equals 3. Then the second part of your recursive rule is going to say f of x equals, what are you doing to the previous term now? Well, I'm multiplying the previous term by 2, so this would be 2 times f of x minus 1. Okay, so that's an example of an arithmetic in a geometric sequence. Okay, so let's look at the next one here. So what this does, they wrote this recursive rule a little differently. They started this, right? They put the previous term plus 3, right? And then your first term here. So right away when it says write the first 4 terms of the sequence, they're referring to the outputs. So that would be -5. Then the next term, what are we doing to each term? We're adding 3. So the next term would be -5 plus 3, which would be -2. But then now I'm going to take -2, my previous term, and I'm going to add 3, so it would be 1. And then the next one would be 1 plus 3, which would give me 4. These would be the first 4 terms of the sequence. If I wrote these as ordered pairs, I know it's 1, -5. Then the second term had an output of -2. Third term had an output of 1. and then the fourth term had an output of 4. And right away when I go ahead and graph these ordered pairs, 1, 1, 2, 3, 4, 5, 2, negative 2, 3, what is that, 1, and then 4, 4. And if you look, when you take these ordered pairs, right, and you look at them, they form a straight line. And if this here, I know it's arithmetic, right, because I'm adding to the previous term each time. Now the explicit rule, right, if I take one of the ordered pairs, say 1, negative 5, what is my common difference, right? That tells me my slope, and my slope m, right, is basically what am I adding or subtracting each time? 3. So my explicit rule for this would be my slope of 3 times x minus, what's the x coordinate of the ordered pair? 1. And then what's my output y for that ordered pair? Negative 5. Okay. Now it says find the value of the 30th term. Well, what rule is easier to use here? It would be the explicit. So f of 30 equals 3 times 30 minus 1 minus 5 would give me 3 times 29 minus 5. And 3 times 29 minus 5, right, is going to give me 82. Okay. So right away here, we're going to go through these pretty quickly. Here, what am I doing each time? I notice I'm going up 8. So right away I know this is arithmetic, right? My common difference, or my slope here, right? So this tells me my common difference is 8. So my slope is 8. And I'm going to take this ordered pair. I notice they are giving me the y-intercept because x is 0. So f of x equals 8x minus 5. Now notice I could also use this. F of x equals 8 times x minus 0, right, minus 5. Either one of these answers would be good. The recursive rule now, f of 0 equals negative 5. Then f of x equals, what are we going to do here? F of x minus 1. And what are we doing each time? We're adding 8 to the next or previous term. Okay. Number 5. Is this arithmetic or geometric, right? If I look here, what are we doing each time here? We are multiplying by 3, which means this is geometric. In this explicit rule, f of x equals, right, my initial value. Now remember here, when you go to do the explicit rule for this, you have to understand for the, since we know this is geometric, we really need when we start at 0. So there's 2 ways we could do this. If I work backwards, if I'm multiplying by 3 each time, if I work backwards, right, what could I do to get this previous term here? I could divide by 3. 6 divided by 3 would be 2. So I'm going to do this 2 ways. One, using that new ordered pair 0, 2. My common ratio is 3. And my initial amount, right, A, is 2. So it'd be 2 times 3 to the x. If you don't want to work backwards and say you want to use this ordered pair 1, 6, you could also use A, which is 6 now, right, times 3 to the x, but I have to subtract 1 up top. That's where it gets a little tricky. So with the explicit rule for these exponential functions, it's actually easier to go back and find the 0 term, right? The value of y when x is 0. The recursive rule, Alright, we're going to say f of 1 equals 6. Then f of x equals 3 times my previous term, f of x minus 1. Write a recursive rule for this explicit rule, right? Right away I have to recognize my common ratio is 8. I know that this is geometric, right? So now all I need to know is a term. So if I let n equal 0, 4 times 8 to the 0 power. If you don't know this, remember 8 to the 0 power is 1. 4 times 1 is 4. So if I have this ordered pair, 0, 4 now, when I go to write my recursive rule, f of 0 equals 4. Then the second part would be 8 times the previous term, f of x minus 1. Because I'm subtracting 8 here for this one, I know this is arithmetic, right? If I'm writing the explicit rule here, I need my slope right away, and since I'm subtracting 8, my slope is negative 8. And I'm going to use that ordered pair. X is 1, my output y is 12. So, remember, for the linear functions, it's m times x minus 1, x minus x1 plus y1. So, it's going to be negative 8 times x minus, my x coordinate is 1, plus my y coordinate 12. Do me a favor, go ahead and try the homework, and let me know if you have any questions.